So we've got a practical 6 marker here looking at an investigation between the length of wire and its resistance. So whenever tackling practical 6 markers, you may have seen my other video on this, you need to remember EMMAs. So EMMAs stands for Equipment, Method, Measurements, Analysis, Safety. So as you're completing your write-up, you need to make sure that you have hit each of those things. So every time we talk about a measurement, we need to make sure we're saying the equipment that we're going to use. And when we're talking about our method, the key thing here is to include things that are going to make it a valid investigation. So I'll walk you through those things as we go through. So the first thing here is we are looking to change the length of wire and measure the resistance. So we're going to have to start by measuring our length of wire, and to do that we're going to need a ruler. But our length of wire is our independent variable, so we know we're going to need to change that. So we need to talk about how we're going to change that. If you can see here, we've got crocodile clips. They can be moved. So we're going to vary our length by moving our crocodile clips. Now we are trying to find how the length of wire affects resistance, and to do that, to find resistance, we need two things. We need the PD and the current, which is why we've got a voltmeter and we've got an ammeter in our setup. So the next thing we need to do is for each value of length, we need to measure the current with an ammeter, and we need to measure PD with a voltmeter. Now we're trying to find resistance, so once we've got those values for current and PD, we then need to calculate resistance using R is V over I. So that shows us what we're going to do. We're now going to repeat that for different lengths. Now you could say what those lengths are. So you could say, for example, 10 centimeter intervals between 0 and 100 centimeters. That's really helpful too, because that shows that you know exactly how this should be carried out. We need to repeat our readings and calculate a mean. And the reason we calculate a mean is to remove any anomalies. If you look at the question, it says that this is about using this at constant temperature. So the last thing we need to consider is how do we control that temperature? So there's two things we can do here. We can keep the current low. And the other thing we could do is disconnect the circuit in between readings, because that prevents the temperature from rising. So if we just check it off against our EMMAs, we can see we've got our equipment. We can see we've got our measurements. We can see we've got our analysis. Our method, well, these are the steps we're going to take to do this. And then our safety, which is also part of our method, is this idea of minimizing the heat, because that will reduce the chance of burns. So which graph here shows the relationship between the resistance of a wire at constant temperature and its length? So the relationship between resistance and length is a directly proportional one. So R is directly proportional to length. For directly proportional, we're looking for a straight line through the origin, and that means the only one that fits is this one here. Student uses a cell that has a PD of 1.5 volts. Explain why the cell was not an electrical hazard. So when we're explaining, we're being asked to say, well, what is the hazard that could be caused, and why does this instance not leave that as a hazard? So what we've got here is we've got a very low PD. And what that means is there's no or less risk of electric shock.